Here we're given an expanded sum, and we want to express this sum using summation notation, which involves our Greek letter sigma. So our answer is going to be something in this notation. And they're telling us to use 1 as the lower limit and I for the index, or the variable in the summation. So our bottom here on the sigma is going to be I equals 1 based on those instructions. So then we've got a couple more things to figure out. We need to figure out what our upper limit of summation is going to be, so when we stop. And we also need to figure out what our expression is that would generate this pattern that we see from one term to the next. So to try to figure out what that pattern is, here in our first term we have 1 squared. So we want to get 1 squared when we plug a 1 in for I. We want to get our second term 2 squared when we plug a 2 in for I. We want to get our third term 3 squared when we plug a 3 in for I. And since I don't know yet when we are going to stop, I can't really say for sure what it is that I'm going to plug in for I in order to get 9 squared at this point. So we need to really just use these first 3 terms to try to identify our pattern. And so my expression that I get is going to involve the variable I. And again, I want to come up with something such that when I plug a 1 in for I get 1 squared. When I plug a 2 in for I get 2 squared. And when I plug a 3 in for I get 3 squared. Well, I can notice there that everything is being squared. That doesn't change. The part that changes there is the base. The base changes from 1, 2, and 3. So those bases actually happen to match up exactly with the values of I that I want to use. So that would indicate that my formula, or my pattern there, is I squared. Now that way, when I plug a 1 in for I get 1 squared. When I plug a 2 in for I get 2 squared. When I plug a 3 in for I get 3 squared. So now looking at our last term, that would tell me that I want to stop when I plug a 9 in for I. So that would give me 9 squared. And so here is our sum expressed in summation notation.